Hello. We are going to continue on and we're going to talk about the three other trig functions called cosecant, secant, and cotangent. All right, remember that each trig function has a unique ratio of sides. We learned this side yesterday, and we held on to this acronym SOHCAHTOA. Now we're going to talk about the reciprocals. The cosecant, this is cosecant, this is secant, and this is cotangent. And these are reciprocals from the ones across from them. So I always write my 6 functions in the exact same order on my paper. And then to help me remember which one is a reciprocal, I start with tangent and cotangent. Because these two have the same word in their name, tangent, it's easy for me to remember that these guys are reciprocals or inverses of each other. But I always struggled here with cosecant and secant. And the way that I finally remembered it was there was lots of S's and C's going on. So I could always remember sine, cosine, and tangent. And then the inverse of sine was the one that started with a C. It was the non-S one. So it goes S and C and S. So sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals of each other. Notice how sine starts with an S. Cosecant starts with a C. Cosine starts with a C, secant starts with an S. So it's the opposite letter, as it were. Okay? Hope that helps. If you want further explanation, talk to me tomorrow. That'll be good. All right? All right, so write the trig ratios of cosecant, secant, and cotangent for each of the acute angles of the right triangle. Include the formula for each and simplify all radicals. All right. So I'm going to focus. I think I'm going to do angle B on this one today. I don't think I'm going to do both of them because the videos are getting kind of long. So we're going to do angle B. The cosecant, we have to label our sides opposite, hypotenuse, and adjacent. Just like that, just like we would with the other three. All right. Cosecant of beta is the hypotenuse, 10 over the opposite 6. So that becomes 5 over 3. 5 over 3. That's a 6. Okay. The secant of beta is the hypotenuse over the adjacent, and that's going to be 10 over 8, which is 5 over 4. And then the cotangent of beta, sorry, that should be a beta, is opposite 6 over adjacent 8, which simplifies to 3/4. And you're done. Just like that. All right, let's try A. Seeing as we did beta last time, let's do A this time. The cosecant of A, well, let's label our sides. We know this one's the hypotenuse. This one must be adjacent. Okay, so I have 6 over 3, which is equal to 2. Then I have, for the secant of A, 6 over 3 square roots of 3. So that's 2 over the square root of 3. I'm going to cram that all in there. Got to get rid of that square root of 3 on the bottom. So it becomes 2 like this. Square root of 3 over the square root of 3 and I get 2 square roots of 3 over 3. That's that answer. And then for the cotangent of A, it's the opposite, which is 3, over the adjacent, which is 3 square roots of 3. Right? These cancel, and I get 1 over the square root of 3, which when I rationalize my denominator, I multiply by that tricky number, square root of 3 over 3, and I get the square root of 3 over a full 3. So that's the answer for cotangent. Here's the answer for secant, and here's the answer for cosecant. Very good? Okay. Again, let's do B again this time. We have here, well, let's do A. I might have more room to work with A. Okay, so here's A. My side opposite is here, my hypotenuse, and my adjacent. So I have 4 square roots of 2 over, the opposite is 4. My 4's cancel, and I'm just left with the square root of 2. The secant of A is hypotenuse over adjacent. So again, I have 4 square roots of 2 over 4, and I cancel, and I get the same thing. Okay. And then my opposite over my adjacent is equal to 4 over 4, which simplifies to 1, just like that. Okay? Very good, very good, very good. All right. Again, sometimes they'll withhold a side from us to make us use the Pythagorean theorem to find a missing side. So in this one, this is my hypotenuse, or C. Okay? This must be a leg, so that's an A. So I have 5 squared plus B squared equals 13 squared. And that gives me 25 plus B squared is equal to 169. And B squared is equal to 144. And B is equal to 12 after taking the square root of both sides. So this is a 12. Now I'm going to go ahead and get rid of other markings and make sure I label my side. I think I'm going to do, well, it's beta, so we're going to do all 6 angles, all 6, okay, all 6, okay, for just this one angle beta, all right. So that means I have, this is my adjacent, this is my opposite, and then of course 13 is my hypotenuse. So here we go. My sine of beta is the opposite, which is 12 over 13. Very nice. Nice number. Just leave it just like that. My cosine of beta is my adjacent side over my hypotenuse. So I get 5 over 13. My tangent is the opposite over the adjacent. So I get 12 over 5. Now look at the order that I wrote these in, because the inverse of sine is cosecant. Remember, we don't want to match our S's and C's. We want them to be opposite of each other. All right, so I'm still at the same angle, but now I'm finding the cosecant. Well, it's going to be the inverse of this. So I can just look straight to the right here and go 13 over 12. And then the secant of beta is going to be 13 over 5. It's the reciprocal. And then the cotangent is going to be 5 over 12. And I've just got all 6 trig functions for that one angle beta. Okay. All right. We have another one here. I know this is C, and this is one of my legs. Let's call it A. So we have to find the missing side. So we're going to use 8 squared plus b squared equals 12 squared. Okay. Remember to write your formula on your homework. That'll help you. All right. And then I have 64 plus b squared is equal to 144. B squared is equal to 80. B is equal to the square root of 80. 5 and 16, 4 and 4. So this is 4 square roots of 5. Just like that. We've seen that before on an earlier video. All right, here is my beta, so I don't have to worry about this one. Let's make sure our markings all are have to do with beta. So my side, this is my hypotenuse, because it's always across from the right angle. This is my adjacent, and this is my opposite. So here we go. Sine of beta is opposite over hypotenuse, so I get 8 over 12, which is equal to 2/3 when I reduce. The cosine of beta is the adjacent over the hypotenuse, so I get 4 square roots of 5 over 12, which is the square root of 5 over 3 after cancellation. This I don't have to rationalize because it is the square root of 5, it's in the numerator. And then the opposite over the adjacent is 8 over 4 square roots of 5. So this is 2 over the square root of 5, which when we multiply top and bottom by square root of 5 over square root of 5, I get 2 square roots of 5 over 5. Hopefully now you're seeing a pattern of how to, of the simplifying, the rationalizing the denominator. Now, what I do over here is I just take the reciprocal. So I'm going to get 3 over 2. I'm going to get 12. Start it here so you can rationalize correctly. 12 over 4 square roots of 5, which is equal to 3 over the square root of 5, which by now we're getting the hang is 3 square roots of 5 over a solid 5. And then the cotangent is 4 square roots of 5 over 8, which is the square root of 5 over 2. Like so. Okay, very good. So now we're hammering through here. Okay, we have 17 and 15, and we're writing trig ratios. Okay, I got to find my side here, so I got to use the Pythagorean theorem. And I have 15 squared plus, I'm not shirking my responsibility. I've written that out. So don't you forget to write that out on your paper in class doing your homework. All right, 15 squared plus b squared equals 17 squared. So I get I did it again. I get 225 plus b squared equals 289. Recovered nicely from that one, even though you can't tell that's a b squared. Okay. I'm going to subtract 225 from both sides, and I get b squared is equal to 64. Therefore, b is equal to a nice number, 8. Beautiful. No radicals on this one. We're rocking and rolling with this one. All right. We're looking at beta. Here's beta. So this is my side opposite. This is my side hypotenuse, and this is my side adjacent. Okay. If you're still having trouble identifying those sides, please come see me. It's an easy fix. We just have to practice it. So don't not come see me. Double negative. Come see me. All right, here we go. Sine of beta opposite over hypotenuse is 8 over 17. The cosine of beta is the adjacent over the hypotenuse. the adjacent over the hypotenuse, which gives us 15 over 17. The tangent is opposite over adjacent, which gives us 8. Ooh, wrong thing. 8 over 15. All right. Now we're going to take the inverse of those. Remember, the trick is sine gets matched up with cosecant. The s's and the c's are matched together. All right. So here we go. I have 17 over 8 for hypotenuse over opposite. Then I have hypotenuse over adjacent is going to give me 17 over 15. And then my cotangent is going to give me 15 over 8. Oh, very good. Here we go. All right, now we can find all 6 trig functions for a particular angle given one of those trig ratios. Remember what sine is. It's the opposite over the hypotenuse. So draw your picture. Pick an angle to be theta. Doesn't matter which one, right? The hypotenuse definitely goes across from the right angle, and that has to be a 5. And then my opposite side has to be a 3. Therefore, I'm looking for my adjacent side. So I get a squared plus 9 equals 25. And a squared has to equal 16 by subtracting 9. So a has to equal 4. And that is my adjacent side. All right, here's my opposite. And here's my hypotenuse. Notice, even though they give me sine of theta is 3/5, I still go ahead and put it in. That way, my all my trig values look the same. I have 6 for everything, and it's easy peasy lemon squeezy. All right, the cosine is going to be 4, which is the adjacent over the hypotenuse, over 5. The tangent is going to be opposite over adjacent, 3 over 4. Now I just take the reciprocals of these numbers here. So this is hypotenuse over opposite, cosecant, and that is 5 over 3. Secant is hypotenuse over adjacent, that's going to equal 5 over 4. And cotangent is adjacent over opposite, and that's going to equal 4 over 3. And we are good to go. We're done. We did it. Wham, bam. Okay, let's try this one. You know what? Why don't you try this one on your own and come back? Also, hint, 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 you can reduce this and it'll make your simplifying easier. So cotangent is 6/4. So go ahead and reduce that to 3/2. Cotangent is what? Adjacent over opposite. Adjacent over opposite. Here's your beta. Okay, now hit pause and try and give it a whirl. Okay, here we go. I'm going to find my hypotenuse. That's 2 squared is 4 plus 3 squared is 9, so that's going to be 13. So C is going to be the square root of 13. So we're going to have some simplifying and rationalizing of radicals here. Alright, so that's an H. This is an A, and this is an O. You ready? Here we go. The sine of beta is the side opposite over hypotenuse. So I get 2 over the square root of 13, which is equal to 2 square roots of 13 over 13. The cosine of beta is the adjacent side over the hypotenuse, so I get 3 over the square root of 13, which gives me 3 square roots of 13 over 13. And my tangent is opposite over adjacent, so I get 2/3. 2/3. Okay. Now I'm going to take the reciprocals of all of these, and I'm going to go into here so that I make sure I rationalize everything correctly. All right. And I'm going to get the square root of 13 over 2. Here we go. I guess I pressed too long or something. I just don't know. Right, so I'm going to write a 2 there. Very nice. The secant of beta is the hypotenuse over the adjacent. So that is the square root of 13 over 3. Notice in these two cases, here and here, I don't have to rationalize the denominator because my square root is not in the denominator. And now my cotangent is what they gave me, which is 6/4 or 3/2. Just like that. Okie dokie. Right, we'll have a worksheet tomorrow. Thanks for listening. I hope you have a great night. Might help you if you just start writing these ratios and get them burned into your brain. Good night. See you tomorrow. Thanks for listening.